So we are going to look at oligopoly right now. So we're going to look at it in two ways. One is with the computer and one is with our pen and paper. So let's start with the computer. And just remember that this bottom corner is kind of blocked. So here's the model we're looking at. We've got a simple demand curve, and that I actually can draw over here. So our price is based on the total quantity, and our price is 100 minus Q. So as we pull this down, it hits Q at 100. Nice simple demand curve. The slope is -1. Not too much to talk about there. Our cost function for any given firm is 10 plus 2Q. So they've got some fixed cost at 10, and then every unit they make, they are adding $2. So the slope is going to be twice as steep. So you'd want to hit 210 by the time we're up here. So we pull that down. And here, that is our cost for any given firm. Actually, we should change this from a big Q to a little q. So this is the demand for the market as a whole. This is the cost for an individual firm. Now, with this spreadsheet, we're going to work, I'll share this, I'll share a link to this spreadsheet, but let me explain how it works. So our overall stuff is calculated over here. We find our price just by using this demand curve, 100 minus whatever the quantity is. The quantity, we're going to ask for all of the firms, what output do they produce? So down here at the bottom is where we're playing around with numbers for the individual firms. So we've got ones and zeros in this row to ask if they are in business. The firm number, it's just, instead of naming, we got firm 1, firm 2, firm 3. That's purely for us. That isn't part of the math at all. So for now, we'll have 2 businesses that are open, and then we've got a few other businesses that have zeros that are closed. Right? So whatever it is that we put in their output, we're going to multiply it by 0 so it doesn't matter. So this quantity, we're getting 25 for an open business, 25 for an open business, 0 for a closed business, right, times 4. That gives us the quantity. The quantity gives us the price. That price times each firm's quantity gives us the revenue. Right, so here we've got a fairly easy formula. We ask, are you in business? How many units did you produce? What is the price that we're getting from the market as a whole? Right, so it's relatively simple math, and we've broken it down in a way that it works for us and lets the computer do the hard work. Here it gets a little trickier, but really not that much. We've got the cost function, so we're just saying your cost is $10 plus 2 times however many units you produce if you're open. If you're closed, we multiply it by 0, so we get these zeros down here. And then our profit is just revenue minus cost. Nice and easy. So 1250 minus 60 gives 1190. And then we can add up this whole row to show the total profit for the all the competitors, right? For the industry as a whole. Consumer surplus is a little bit trickier. What's going on there is we find out what quantity do we get, right? So we get some quantity based on how we think about how the firms respond to their possibilities. So we get some price, and then our consumer surplus is just this shaded in area, below the demand curve, above the price. So what's the size of that? Well, it's 100 minus the price gives us this height, and then whatever our quantity is gives us the base, and that gives us a rectangle that we can cut in half to get this triangle. Base times height times 1/2 gives us this area. This is easy. This is just, we have to find Q, right, which we've got right up here. So consumer surplus, it takes a little finagling to set up the equation, but conceptually it's easy. So you just take your time, you figure out how that's going to work. Now, what you can do with this is fiddle around with the numbers, right? So ask what happens if we have a third firm and they're all selling 25 units. What if they're all selling 20 units? We can update what we've got in this row, right? This is sort of where all the action is. In this row, this is where we're bringing these firms' decisions, we're making them actually impact the market, right? Versus they would make 25, but they're not in business. Doesn't matter. Right? So we can play around with stuff and we can see what happens as far as consumer surplus, total profit, and the profits of individual firms. And here is really where things get interesting, because we can ask a question like, well, what if this firm produces one more unit? They go from 750 to 767. Okay, so if that's the case, then it makes sense for them to do that. Well, how does this firm respond? What if they produce more? Hey, they make a little bit more money too. So we can kind of bounce around and plug in different numbers to figure stuff out. In a perfect world, we would also have Solver working for us. Unfortunately, Google Sheets doesn't have that as of this video, but we can come back to this. I've loaded into LibreOffice. This is going to work very similarly to Excel. And again, we can try different things. This is the exact same spreadsheet, minus one modification, which is I added a couple columns. But we can ask questions like, if these two firms are going to do this, then what does firm one want to do? Right? So they're going to target their profit cell, cell B12. They want to find a maximum value for that by changing their own output. Our limiting conditions, I'm not going to worry about that. We're just going to see what do they do to maximize their output. We hit solve, and it says, oh, no good answer. And that's basically because already we've got two firms that are producing sort of too much. So there's not a whole lot of room to grow. Let's try it like this. Knock their production down to 10. Do the same thing. Hit solve. All right, this is not working. Maximize profit by changing the output. That should do the trick. Huh. All right, well, I take it back. Solver isn't the key thing here anyways. So let's move over to the calculus, over to the algebra and finding this a different way. But just because it's going to drive me nuts if I don't, I got to fiddle around with this a little bit. 12, 13, 15. They're still making more money. 5, 30. Ooh, I think I know. 30 is still not maximized. All right, well, I can go all day with this, and that's only going to distract me, so let's switch over to my notes. So, same model, right? We've got our price, our quantity, we're calling Q1 plus 2Q, Q2. I also do a little different thing. I should have done, actually, let me go ahead and update this. We'll call this QI plus QJ, right? So QJ is just the firm that isn't firm one. So what firm one makes, what the other firm makes, or we'll see, we change that in a little bit to what the other firms make, to ask the question of what happens if we've got more than two firms. We got our same cost function, 10 plus 2Q for any given firm, that is their cost. And then we have to ask, well, what do they actually care about? They care about maximizing profit. Right, so maximization, this brings us into the realm of derivatives and optimization if we're watching this video for Eco 250. If we're watching this for 330, don't worry too much about the math itself. Follow along as best you can. So our profit is just, let me switch colors just to make this stand out. It's total revenue minus total cost. And our total cost is just $10 plus $2 per unit. Right, so that is going to be minus our cost, so minus 10 minus 2qi. This is for firm I. We use pi for profit. So profit, our revenue minus our cost. Our cost is pretty easy. Our revenue is price times quantity. Right, so it's going to be this price times the individual firm's quantity. Right, so here we've got 100 minus qi minus qj, right? Q minus q, right? Minus big Q is qi plus qj. So we get minus signs throughout. 100 minus qi minus qj, all of this times qi. Right? This is our total revenue. Let's just highlight this. Total revenue. And over here minus total cost. We do a little bit of rearranging, and finally we get profit. This is our objective function. The firm has this objective. They want to maximize their profit, which is minus qi squared plus 98 qi minus qi times qj minus 10. Right? So their profits, they always lose 10 for that fixed cost. They get more profits as they sell more, but they lose some profits in the quadratic term, right? So we're getting something, it's tough to see, but we're getting something that is sort of parabolic like this, right? It's hill-shaped. So it's shaped basically like that, and we're going to ask, where do we hit that maximum? Where do we find the highest point on this curve? Now, the calculus of this is if we can find a formula that gives the slope of this function, we can then ask, where is that slope function equal to 0? Right? We show the slope with pi prime. This is the first derivative. Right? Pi prime is, we use calculus to convert our objective function into a function that gives us the slope of that line at any given point. So our derivative is minus 2qi plus 98 minus qj. Right? Let me take a second and step back here also. So our profit, it's increasing in this parabolic shape with our own decision about how much to produce. But as far as the other firms are as far as they're concerned, their impact on my profits are that they sell more, I lose money. Right? I get minus some quantity times their quantity. The bigger their quantity is, the bigger this negative term is. Right? So my profits get hurt by my competitors deciding to produce more. So obviously I don't want them to, but I don't get to decide. So we're going to start with a symmetric duopoly. Right? What that means is we have one competitor, me plus the other guy. And what we've got here is this very Cournot graph. We've got our response functions. And this is where Cournot is kind of getting us a little bit of industrial organization in terms of what happens with the duopoly, but he's also giving us very early game theory. He says, what does firm I want to do based on what firm J does? So if firm J sells more, then firm I wants to sell less. If firm J sells 0, we're going to show that firm I wants to sell 49 units. But as firm J expands output, firm I is going to contract. Firm J is going to face a very similar thing. So here we can sort of imagine flipping this and asking, based on QI, how much does firm J want to produce? So if QI is 0, then firm J wants to sell 49, but they're going to sell less than that as this number increases. And we're going to find our symmetric equilibrium where these 2 points cross. Now, that was abstract and weird. Graphically, let me show you the equations underlying this. So, again, our first derivative tells us the slope of this function. And we're going to find where is that slope 0, because that's when we're peaking. That's when we're maxing out this parabola. And we double check the second order condition. So 250 students, we take the second derivative, which is the derivative of this. And with that number, we find that pi double prime is -2, which means there's just one maximum. Right? It's always open down, is what this second derivative shows. All right, so where is 0 going to be equal to -2qi plus 98 minus qj? We do a little bit of algebra, right? So add 2qi to both sides, we're left with 98 minus qj. So for firm I, their profit maximizing quantity, the quantity where we're maxing out this function, is going to be at 49 minus qj divided by 2. Okay. Twice their quantity is 98 minus qj. The quantity thereafter is 98 over 2 minus qj over 2. So now we've got a solution for q, and if we assume that qi is equal to qj, this is our symmetric solution. We've got two firms, they produce the same amount. They're going to produce so that q is equal to 49 minus q over 2. We do some arithmetic and we get just about 33. So let's jump back to the computer and see how that shakes out. So if we've got 0, 0, 1, 1, two firms, they're both producing 33 units. What happens if we go to 34? 1046 is their current profit. That goes down to 1044. So if they're here, firm 1 doesn't want to produce more, firm 2 doesn't want to produce more. What about producing less? 1046 stays at 1046. All right, so we are pretty close. Certainly 31, we lose some profit. So let's see, if we're at 32, what happens if we go 33 to 32? 1079 becomes 1078. So 33, okay, it's about there. This should be 98 over 3. So let's put that in. 98 divided by 3. There we go. So it's a little bit less than 33. 98 divided by 3. So if they're both producing this, what happens if we go to 33? 1057 and 11 cents goes down to 1057 and 0 cents. So producing more, you lose 11 cents of free money, 11 cents of profit. So you don't want to produce there unless you can only sell discrete units. Then you're going to sell 33. What happens if you cut back to 32? 1056, so you're doing even worse. How about 32.6? So you're making 10 6/10 cents rather than 11 cents. 98 over 3. So we make a half a penny more at this solution. So that is our solution for duopoly. If qi equals qj. If we have a monopoly, we're saying qj is going to equal 0. There's no other firm. And in that case, qi we want to set to 49. Something to notice is we're having individual firms sell less, but collectively they're selling more when there's two of them. Right? Two of them, they want to sell about 64 units. One of them, they want to sell about 49 units. If there's three of them, then we modify this. We're going to say qi. We're going back to this equation. Right? This catches our most important stuff. And actually, this is equivalent to the purple line here. But we're modifying that to fit what's going on. So by setting the equation equal to this so that qi is equal to 1/2 of what everyone else produces in qj, then our result, when we solve for everything, is we get about 75 units all told. Each individual firm is selling about 24-ish. All right, that was a lot of stuff, but we've got that recorded so you can pause and rewind. And if you've got questions, feel free to ask in the usual places.